presentation. So I'm going to introduce Hiep Nguyen. Is that correct?
Perfect.
Okay. Hiep Nguyen serves as the Smart City Officer at the City of Winter Haven. He has a background in biochemistry and sociology and works to leverage data-driven solutions and innovative partnerships to enhance the city's operations and quality of life for residents. I'll let him introduce his colleagues and to Doc.
All right, good afternoon. I'm Hiep. That's not a statement, that's actually my name. And I serve as a Smart City Officer. So my job is to make the city smart and hip. And hopefully by the end of our presentation today, you'll be a little bit smarter and hipper as well. All right. So with me is our young data team, our business intelligence and GIS team, codenamed Skunk Ape Works, and I'll explain that in a little bit. But we're just going to go straight to our video. Okay. All right. See what happens when you recruit game developers to become GIS people? All right, so I'm going to talk a little bit about our Lake Elbert Trail. They're going to introduce themselves when they come up, but actually, this is Chris Duclos, Michael LaFollette, and Nickolas Phan. These guys are a brand new data unit for the city of Winter Haven. We didn't have this capability 12 months ago, so they just came on board and they just ran with it. And this is just one of the things that we're doing, but we grabbed on to doing a digital twin of the Lake Elbert project. And what does that mean with the digital twin? They'll go and explain the whole process of how they've done it. And then also Nick is going to talk about some of the advanced things that we're exploring into being able to merge the GIS and the Unreal Engine world, kind of like the chocolate and the peanut butter. They're doing amazing things. All right, so I'm going to talk a little bit about the Lake Elbert Trail Digital Twin, or the Lake Elbert project. This has been a project that's been in the community discussion for decades. And it was in the last few years that we started partnering with the property owners, and without eminent domain, we worked to go in and acquire the land to go in and build this trail. So it's a very long awaited project with a lot of upgrades, from fiber optic into the ground to the new sewer system, water system, a concession stand, a boat ramp. So a lot of improvements to this particular trail that goes around the lake, but also something that's been that we look forward for the longest time. This trail started construction early this year and is expected to be complete by the end of first quarter, beginning for second quarter of 2025. So this is an active construction. What was depicted was taken from engineering drawings to kind of showcase what would this trail look like. And it was a very quick project. It was surprisingly, it was just a thought experiment, but we thought it was a great way to kind of showcase some of the new things that we're doing with GIS, with the use of the Unreal Engine SDK for ArcGIS, and then also a lot of programmatic Python capabilities as well. But that's, I only have a few slides, right? Right. So this talks about some of the upgrades that are part of that. Rain gardens. We have smart trash bins. So we actually build and design fiber to our trash cans so that we'll have very trashy Wi-Fi, pun intended. And then paving the whole corridor, right? So again, completion is by April 2025. Now I'm going to go and introduce Mikey and Chris in terms of how they actually created this digital twin. And so just having them kind of explain to you how the sausage made is very interesting, right? With that.
All right, good afternoon, everyone. I'm Chris Duclos, one of the computer scientists at the city of Winter Haven. So to kind of introduce the idea of our digital twin project, I think it's important to talk about the big focal point in the video we showed you, which is the fact that when the camera zoomed above the lake itself, you could see the city behind it, right? And so we did that using Google Map tiles. And so what you saw in that video is actually just the tiles of the Google Map basically put into 3D and depicted, rendered within Unreal Engine 5. And so if you were to theoretically take the camera and zoom out further, you could see the entire city and then the rest of eventually Polk County. But focusing in on the digital twin and on the trail itself, we wanted to use Unreal Engine 5, which has a lot of tools that integrate with these various things in order to, make a realistic trail. And so as Hiep mentioned, we took the engineering drawings of what the trail was going to eventually look like, and we actually went in and made splines that depict the trail as it's going to be. And so what you saw in that video is a realistic depiction of what the trail is going to end up looking like when it's done in construction. And so what that does for us as we're sort of getting that construction underway is it allows engineers or folks who just want to see what their trail is going to end up looking like, have a interactable version of what that'll be, instead of just having to rely on a 2D drawing that might not be super easy to understand. Not only that, we did some interesting things using dynamic water and dynamic lighting and weather, things that Unreal Engine 5 is already powered to do, via making video games, but instead we wanted to use it to make a realistic simulation experience. And so what we've been able to accomplish is, when it is daytime outside, the game will be in daytime. When it transitions to nighttime, it will be a nighttime scene. If it's raining, you can have the rain be visible if it's storming. And so what we end up wanting to do with that is fully tie it in one-to-one with our actual live data, right? So if we know that if we know that a storm is coming, rain should start, rain should pick up. If there's thunder, there's lightning, we can actually depict that. And we've heard much talk about another storm potentially coming our way. In the future, we would love to be able to say, hey, if we're about to have a torrential rainstorm or a hurricane hit our lakes, what could the flooding potentially look like in a 3D environment that we can have our EOC team take a look at?
Hi, I'm Mikey LaFollette. I'm one of the Smart City computer scientists with the City of Winter Haven. My GIS background began 10 months ago in February. So prior to that, I was a student at Florida Polytechnic University, where I studied game development and graduated with a degree in computer science. So I'm just going to walk you through a little bit of the making of the project. So there's a couple and kind of eyeballed it, basically. Just eyeballed it for the landscape. At that point, I had added one of it. There's some visual effects for customize. Unreal Engine is very powerful in being able to do whatever you imagine you'd be able to do, you can pretty well figure out a way to do it. So here we've implemented the Google Earth tiles using a plugin called cesium ion. Funded by fully looked at, but it didn't really come together at this point. Trees and grass, and so the idea with this is that obviously is that the more visual you are, the more personal it is to the people looking. And so this is something we're hoping to engage the community, maybe city officials, people who don't live in the city perhaps, to kind of become acquainted with that. So this is actually how Unreal Engine works. So it's not the traditional typing, coding, hacker man. It's those blueprints. So it makes it very beginner friendly. And we've actually had success with our volunteer program getting high school students helping us out with this project. So there's our actual digital twin, Chris Taylor, who's taking photos of us. He has scoliosis. Everything's a work in progress, definitely in the alpha stages. Breathing underwater, as you can see. Now he has actual clothing on, which is pretty yeah, but we're able to scan people. There's our chef friend. We're able to scan people and kind of represent them in the game. And it just adds another layer of personality. Relate to your own character in the game. I mean, there, they weren't Haven. There he is. In a chef outfit. I did not get consent to put him in a chef outfit, but there it is.
His hair is perfect.
Yeah. I modeled me, so it looks really good. But this is the level of quality that Unreal Engine kind of just is everywhere. I mean, this was plugins that we bought from the community. There's a lot of good community support in Unreal Engine. It's a video game engine. Love video games. People make stuff all the time for video games, and it just transfers really well.
The trees that you saw, not the healthy ones, but they're actually from a pack created by UCF, where they actually took South Florida and Central Florida tree data and added them and made assets for them. And so what we hope to be able to do is use our actual GIS tree data that we have and scale the size of the trees relative to how large they are and actually at the lake. And so we're really happy that we were able to find a locally made from UCF source of foliage that is actually realistic for what you might see there.
As Chris kind of alluded to, and I alluded to earlier as well. Well, here's a video game element. What we're doing, but I kind of eyeball it a lot. If you know SDK for Unreal, we're able to actually pull our data from our online and display them in Unreal Engine, and so you can walk around that world, and the data will be accurate, and it will have all of our city's data that we. So. Actually, that kind of easily passes over to Nick and what Nick's been working on.
Yep. And so we'll be passing on to Nick to talk a little bit about the next steps and what we're looking to do with this technology, incorporating our real bathymetry data that we've gotten and recorded over the years.
Hello everyone, my name is Nickolas Phan. I graduated from Florida Polytechnic University with my bachelor's and master's in computer science last December of 2023. I joined the city of Winter Haven in just this last June, and I started working with ArcGIS just this last September. So I'm very much a beginner. If anything I say is like elementary or just roll your eyes, sorry in advance. But so ever since I started working in the city of Winter Haven and with Mikey, I've heard about his digital twin project with Lake Elbert, and I've heard how he's made it in Unreal Engine, and Unreal Engine has a plugin, ArcGIS SDK plugin, to incorporate, ArcGIS elements into Unreal. However, he had difficulty using the plugin, whether that's due to like some dated documentation or like, a fault on our end. So he had that issue. And so what I set out to do was to resolve that, work more on integrating ArcGIS, the ArcGIS SDK plugin into the Unreal project, as well as programmatically and directly integrate our city's ArcGIS data into the Unreal project. And so, as Mikey has shown earlier, we are able to get the SDK plugin to cut out like the extent of where Lake Elbert is. And we're able to display various ArcGIS online layers inside the SDK plugin, such as 3D object layers, scene layers, tile layers, and I believe vector tile layers. However, we're not able to, or the SDK plugin itself isn't able to display feature layers, which is the majority of what our city's like ArcGIS online database is comprised of. Things such as like street signs or manhole covers that we have like data on online, we aren't able to pull it in and show it inside Unreal. And so what I set out to do was programmatically pull that data, outside of say like ArcGIS Online and the plugin inside Unreal, and inside of Unreal's own coding environment, blueprints that Mikey mentioned, which is by the way built on top of C++. I set out to basically grab that and in a separate, like, I guess not as clean way, put it inside. And so how I did that was basically I was able to, on our ArcGIS online database, go to say a feature layer. Say I'll go back to the street signs layer, and at the bottom of its info page on the website, there's a service URL, and inside that service URL is like a very basic HTML web page, where you're able to interact with the REST API that I believe Ezra uses to allow you to access your database information. And so using that REST API, I was basically able to grab that URL, and inside a separate coding environment, Unreal's coding environment, I was able to perform an HTTP request and grab that feature layer's data and manipulate it how I see fit. And so say, for example, the street sign layer had attributes and details such as like what kind of sign it was, as well as its location, like its coordinate, like geographic location, in like say latitude, longitude. And inside Unreal, I was able to use that data to place it like on the ArcGIS like map inside Unreal, like accurately where it is actually supposed to be. And which isn't that like insane to think about, because you could already do that inside say ArcGIS Pro. But in a separate environment like Unreal Engine 5, it was a really big step to complete, to be able to, I guess, step off the path and go outside think outside the box and such. And so I was able to do that for street signs, manhole covers, etc. Basically anything we could add to add detail to say, and basically augment Mikey's digital twin project. But the thing is, those were all point layers. Like each one, say sign or manhole cover, those are just like points on the map. Like you just use like one coordinate to represent where it was. And so by chance, I was talking to Mikey one day, he showed me the bathymetry layer, and I started experimenting with that. And inside the bathymetry feature layer, it's comprised of not points, but polylines. And so that posed like a different challenge. And it was also at this point that Mikey brought up inside Unreal, that Unreal has its own function to create landscapes, given a height map, or like say a black and white grayscale image, where like darker colors say like indicate depth and lighter colors like height and such. And so that was my next objective. It was to use these, say, bathymetry layer, like this bathymetry layer, to create a height map, or say a depth map. And I was eventually able to create it. It was there was a lot of trial and error. It took me a pretty long time, but that image you saw just now that Mikey showed, that was the results that you can see inside Unreal of creating the landscape. And that was like using data that I pulled from our ArcGIS online database. And so that was a big step. That was a big accomplishment, I consider. And so our next step was to branch out and like not just the depth of Lake Elbert, but also the surrounding area. So the elevation data. And so we also have a contour feature layer in our database. It's made from USGS's 2017 LiDAR data. And I was able to basically use the same process to create another height map to show elevation data. And I combined them together. And this is the result height map. As you can see, Lake Elbert is right there in the center, as well as the surrounding lakes and the surrounding area, with the darker colors showing the depth and the lighter colors showing the height. And using that height map, we were able to create the landscape inside Unreal, and we were able to export that as basically a file that we could use to 3D print the actual landscape. So this here is our 3D printed representation of Lake Elbert that uses that contour and bathymetry data to show like the how it actually would look in real life, at least according to the data that we have.
Mhm.
And we want to pass it around.
So if
It's
we-
kind of small.
So if we were able to stop and say, what does that mean? Is that he's able to take data that's available to the public, the USGS LiDAR data, and then the bathymetry data that we have, and programmatically create a landscape in Unreal, allowing us to be able to 3D print it. What that means is we could do that wherever there is LiDAR data from USGS and bathymetry data. So the idea is we could pick your city and 3D print that, and he solved it. So whereas Mikey manually took the bathymetry data and tried to eyeball it, this is making it precise based on the data that we have. So what does that mean? If we could go in and make it accurate, the flood simulations will be more accurate. In terms of all that interaction with true topographic and bathymetry data, we could go in and now rely on that to be able to go in and generate our simulations and so forth. So, and to be able to solve that in over a summer, that was just truly amazing. So right now our natural resources people say, hey, can we print every lake? So, and it's a great way to teach kids about geography, right? So here's something you could touch. Literally, I sat in front of my boss and I showed this to him, and they immediately realized the value of it versus something that I could print or show. This is something you could touch and say, oh, I didn't know it was that deep. And then our assistant city manager, who came from the natural resources world, started explaining all that. And so it allows us to open up conversations to people who are non-GIS, non-technical, to have something that's tangible. I'm also going to plan to put in resin on there. Yeah, light blue, but it's really light green.
Yeah.
But the idea is then we could get, hey, the color of the lake is the quality of it. This is how we would shine the light. And if we had a multispectral camera, I'd be able to use that to assess water quality. So it opens up these type of conversations. And so I'm not sure that Nick realizes it, but to me, it's like, wow, that's a whole lot of value that we got unleashed.
And sorry, just one last thing I wanted to add on. So as you guys can see, as it goes around, The 3D print, it was created from our ArcGIS online databases, contour and bathymetry data. I didn't create the contours myself. And so one flaw you might sort of see, if you could consider it a flaw, I guess, is that in the contours, there's like some unwanted like elevation data. Like if you see like near, I think the top left of Lake Elbert, there's like some raised buildings. I believe that's Polk State. And so that's unwanted. We want just the ground data, you know, at least like at this point, that's what I'm trying to aim for. And so the next step, like, because like the 3D print itself, that's like a big like step to accomplishment. And so the next step that I took was to create my own contours essentially. And so I've heard a lot of discussion about the LiDAR and point cloud data. So I myself have downloaded the USGS 2018, I believe, LiDAR point cloud data, and I've been working with it, and I've used some classification functions and a deep learning model to basically strip away like the vegetation in the buildings and to create my own contours. Well, that's like in process right now, but that 3D model right there, I believe it can be improved, and we're still working on improving it. And yeah, that's it for me.
All right, so I just want to talk about where these group came from. So this group that we have is called the Skunk Ape Works. It's a portmanteau or a combo word, kind of like a spork. Basically, it's a combination of Skunk Ape, which is our own Florida big hairy cryptid, and Skunk Works, which is coming from the aerospace industry, like an innovation team. So our group is called the Skunk Ape Works because we're here to chase after big, hairy, audacious goals, right? So that's a business term. And what happens is sometimes you have to, as an entrepreneur would think, is that we're incentivized to do incremental improvements, right? Because it's safe and it's in front of us. Entrepreneurs typically build companies based on magnitudes of value. And then, so what we're really trying to do is, hey, what are those projects that will increase magnitudes of value for us? And those are the things that we're building to chase. Because they're young, they can survive being fired up. Just kidding. Whoa. Now, these guys are fantastic. So we've been proving value since they've been coming here. So what are the big audacious goals? Well, one is how do we attract talent, right? So how do we bring people into GIS? Bringing people into IT, how do we bring people into government IT? So what we would do is we create honeypots to attract talent, and having kids be able to build their own games, be able to go in and get a drone pilot and fly a real drone. So these are things that we invest in the city of Winter Haven to draw the talent in, and then we go in and we say, what's that? What's the business value that we're attracting? And let me show you some of the things that they're working on that's pulling value. We're using AI predictive modeling to do lead copper rule. So we're working with Trinix to use machine learning that allows us to reduce the amount of diggings we have to do by 80%. We initially, in front of the city commission, we said we would save about $4 million. We missed the mark. We're actually going to be saving more, $8 to $10 million off of that project. We're also going to be chasing using AI predictive modeling for water leak detection. It's a program that we're going to call the 1%ers. Basically, we are losing about 7.35% right now in terms of unaccounted for water. If we reduce it to 6.35, we'll save the city about $1 million, $1.5 million a year, every year. And that's the first percentage. That should be easy. Then we'll chase the next percent, and the next percent. How we're doing that, we're going to use, if you guys heard about, know about Astera, uses satellites to go in and do moisture detection. It's a technology to develop to find water on Mars. So they didn't find much water or any water, so it's pointing towards Earth. And so it's a 60% hit rate. We're going to use that. And if we could reduce it by 1%, that's $1 million, $1.5 million in savings. So those are the projects that we chase. And so things that are meaningful, things that will progress to say, that's why we spend money on GIS and the talent. And it's not just the tools, we got to attract and recruit talent. And we're kind of non-traditional that way, coming from, gaming specialties to different, so my degree is in biochemistry and sociology, and it's worked very well in government because most of technology isn't about technology, it's about people and how they change and adapt to technology. These are the other things that we're chasing it. We're tracking, we're doing poop monitoring, using AI to monitor waste to make sure it's clean, which is a paradox. But the idea is that if we track where the contamination occurs at the source and treat it, we could actually save about $70,000 of worth of chemicals and electricity to not have to deal with the contaminated waste. Because that information will be useful when we build our $500 million advanced water treatment facility. We want to build our innovation capacity, so we try to create honeypots, as I said, to attract and to retain talent. I have 15 people in my IT staff, but I'm approaching 15 to 20 volunteers and interns from the local colleges and universities and high schools, and to be able to build that. So, and we're deeply vested in what's being taught in high school and middle school. So we're part of summer camps and community stuff. So that's who we are. So that's where this digital twin is coming from. It's just, we didn't really mean to do that, but it kind of fell and say, oh, what are you good at? Gaming? Oh, do you want to learn GIS? Boom. And so now that's where that came from.
Any questions?
Q&As.
Yes.
I noticed when I was using the USGS vector tiles on a park, what was your render time on the project for the lake, and what size was the outcome? Because I was already running into storage on a 4-tile vector package, storage issues.
So at our office, we have pretty powerful computers. So
They built it themselves.
Okay.
As in working inside ArcGIS Pro, working with the point cloud data and how dense it was, it's maybe it lags every few seconds. The biggest, I guess, hiccup I would say when it came to, I guess, classifying it was, yeah, those classification functions and the deep learning model that I used. Those ran, like each of them ran about, I want to say 5 minutes,
Oh, you
maybe
definitely have a powerful machine. Mine was
15
like-
minutes total.
Yeah.
And I did
Okay,
not.
I was just curious. I haven't spoken with anybody else that had attempted it outside of my own.
Yeah, so we're we're the IT department, so we build computers and we custom build computers. So if they could build a really cool computer, they could build any computer. But point cloud is very unwieldy, right? So Chris Taylor over there, our other ape, deals with the photogrammetry in the point cloud. So a lot of it is leveraging maybe cloud technology. So, and also the key is how do you smooth the data as soon as you can, right? So points are very cumbersome. So instead of 10,000 points, you just do pull 4 points to be able to represent a wall, right? And so by leveraging how gamers try to maximize gaming, it's the same concept, right? So if you have the gamers game development mentalities, how do I smooth this? So so kind of like the Google tiles, we don't have to do full rendering of the trees. It's just they're so far you can't tell, and so that's how you be able to go and use those tricks to kind of be able to deal with such large data.
Any other questions? Yes.
Are you thinking about using a drone to capture your own like digital terrain model for an update on your digital twin?
Absolutely. So we are going to buy a fixed wing Wingtra drone made in Switzerland because we can't play Chinese drones. That will have a 61 megapixel camera, and we'll probably have to wait 1 year for the LiDAR because the LiDAR sensor is about $50,000, right? So we got to prove value. So we're not reckless. That's one of the key thing is, you know, it has to be magnitudes of value. So it's not like, hey, I got a 10% increase. This, we want to chase things that are game changers, right? Because if we were able to do it, it reduces the risk for every municipality that's starting to do that. And also what we learn in terms of programmatically, you don't have to do that. Here's your college students. You could actually create your own 3D model, your topography, by just leverage that. I think that's the value that we have in these conferences and strategically trying to meet and share information is that a lot of the stuff can be shared readily. We just got to meet up and talk more. That's really the biggest issue.
Any other questions? All right, thank you.